injection takes place. When it's time to stop injection, the ECU commands the needle control valve to close, resulting in a pressure buildup above the nozzle needle, closing the nozzle, stopping injection. If multiple injections were warranted, the ECU could reactivate the needle control valve. As this isn't the case in this instance, the ECU could command the spill valve to open, lowering the internal pressure within the injector, even though the pumping plunger is still descending. Let's take a look at our EUP system. The engine division of DAF, whose parent company here in the US is the more familiar PACCAR, has been using Delphi's electronic unit pumps and smart injectors since 2010. John Deere began OE use of our electronic unit pump with a mechanical injector back in 2008. For heavy-duty applications utilizing the lower-cost design of a low-mounted cam-in-block camshaft, EUP is a viable option. The EUP can be mounted in the engine block or in a cam box as an upgrade for an existing inline pump application. Early EUP utilized a conventional mechanical injector. Later designs included a smart injector, giving common rail and E3 functionality on heavy-duty applications. A typical EUP installation is shown here. Here we can see a typical EUP system layout showing how the various sensors feed data back to the ECU. Next, let's take a look at our F2P system. The F2P distributed pump system is intended for heavy-duty applications that want to upgrade their existing EUP system to an ultra-high pressure common rail system. As with the previous EUP system, they can be mounted on the engine block or in a cam box as an upgrade for an existing inline pump application. The EUP constantly charge up the common rail. Depending on the power requirements of the application, between 2 and 6 pumps would be utilized. Our current applications have 2 pumps. Additionally, we also supply the ECU on this system. Let's take a look at a typical F2P system in operation. The most recent addition of our All Makes program is the Delphi F2 pump and injector used on the PACCAR MX-11 and 13 applications. The next evolution of F2P system is F3P, which is similar to F2P, however with pressure capabilities up to 3,500 bar. The next heavy-duty system to highlight is F2E. Here we can see that this version of F2E calls for 3 pumping injectors and 3 non-pumping injectors. The 3 pumping injectors feed pressurized fuel to the rail, which distributes it to the 3 non-pumping injectors. Some of the benefits include fewer pumping elements, which reduce engine stress, reduce mechanical noise, and lowers cost. System pressures up to 3,000 bar. Let's take a look at a typical F2E system in operation. The last heavy-duty system we'll review today is F2R. This system is intended for heavy-duty applications that want to upgrade their existing EUP system to an ultra-high-pressure common rail system. Let's take a look at a typical F2R system in operation. We build added value in our products. Many of the later technology all-makes reman injectors we sell have either a trim code or a unique trim code file associated with them. To help explain what trim codes are and why they're needed, let's start by reviewing the hydraulic and electronic delays within an injector. Here we can see the start of the logic pulse compared to when the needle lifts and injection of fuel into the engine combustion chamber occurs. We need to visualize a clock running in microseconds. Although we have a 90-volt logic pulse, we have to wait several microseconds before we have sufficient power in the drive circuit to pull the spill valve armature against the armature spring. The spill valve armature is now starting to lift. Again, several microseconds will pass while the armature travels to close the spill orifice. At a point just before the spill orifice is completely closed, injection pressure will start to build up. Injection pressure now builds up to nozzle opening pressure and the nozzle needle starts to lift. Once fuel reaches the nozzle spray holes, the nozzle starts to inject fuel into the combustion chamber. Injection pressure continues to build up and the nozzle needle raises to full lift. Slight differences between injectors, such as machining tolerances, friction between parts, and magnetic forces influence injector operation, which needs to be taken into account. In service, our A-series injectors go through a grading process. Injectors with grades at both extremes shouldn't be installed in the same engine. During the reman process, proprietary test software is used to confirm the injector grade. We ensure our reman A-series EUI all fall within the center of the grading scale so that they can be used without grading issues. Our E1 series EUI have a 6-character grading code etched on the electrical header, which must be entered into the engine ECU during injector installation. Our E3 series EUI have a 9-character grading code etched on the electrical header, which also must be entered in the engine ECU during injector installation. These trim codes can carry as many as 6 parameters to correct for spill control valve, needle control valve, main and idling fuel characteristics. F2 product have a 40-character alphanumeric trim code. Fuel delivery trim correction is analyzed at 5 different pressures and numerous pulse widths. As you can see in the before and after graph shown, trim codes allow for the use of injectors that would normally be outside of the usable limits. Trim codes tailor the performance of each injector to more closely match the output of the target injector shown in red. The latest trim code technology narrows the fuel delivery band even tighter. For applications that utilize trim codes or trim code files, it's imperative that the trim code is entered into the engine ECU at the time of injector installation. The code can be found on the injector. This injector has a 20-digit trim code. Let's take a look at what happens if a trim code or trim code file is not uploaded into the engine ECU. As an example, if the original injector was at the high limit, the trim code would have instructed the ECU to drop the fueling down to the target. If the replacement injector was at the low limit and the new trim code is not entered in the engine ECU, the ECU will still think it needs to drop the fueling, resulting in the delivery being well below the low limit. So if all of the injectors are changed without uploading the trim codes, fueling could be all over the place. This could result in rough idle, low power, high power, white smoke, emission standards not being met, or in extreme cases, engine damage. Uploading the proper trim codes or trim code files into the engine ECU ensures optimal performance. Some techs think that the trim code only affects the idle performance. This isn't the case. It can affect the performance throughout the speed range. In extreme cases, as we can see here, engine damage can occur. We include value-added information with each injector designed to help reduce the likelihood of customer returns due to faulty diagnosis or installation. We developed the Delphi Trim Code Loader program for installers that don't have access to CAT-ET or other tools that can upload trim code files. Information on the Delphi program can be found on our website at www.delphitrimcode.com. On the website, there's a link to a demonstration video which covers installing trim code files using the Delphi Trim Code Loader program. It also covers swapping injectors between cylinders as a diagnostic aid. C7 injectors, along with one part number each on C13 and C15, require the use of a trim code file. Originally, we supplied the file on a CD boxed with each injector. As many diagnostic tools are now being supplied without CD-ROM drives, starting earlier this year, the files are now included on a USB flash drive boxed with each injector. While some aftermarket competitors might claim to provide trim codes, in some cases they're passing on trim codes that came with the original injector. Delphi trim codes, however, are created new as part of our remanufacturing process and are unique to each injector, something many of our competitors can't claim to do. Here is some additional information worth noting. A fault with the fuel injection system can usually be detected by observing one or more of the symptoms listed here. Injectors can fail in service for many different reasons. The most common failures are the result of either contamination, incorrect installation, or improper handling. The tolerances in modern high-pressure fuel injection systems are measured in microns. Here you can see the small red dot indicating a micron compared to a human hair. With clearances down to 1 micron and service finishes less than that, improved fuel filtration is required. That's why fuel filtration down to 2 microns is specified. Using a quality product and following proper repair procedures reduces the likelihood of costly customer comebacks or future repairs. Always handle cores with care to reduce external damage and contamination. Proper handling of injector cores helps reduce repair costs. We have a comprehensive line of OE and all makes product to support the repair network. The D next to the products shown indicate that we're the original equipment manufacturer of the product. We leverage that OE experience to remanufacture our OE products as well as other products in our all makes line. We're also original equipment manufacturer for the solenoid and spill valves on the 4 CAT applications indicated by a D on the upper row. "75% of offerings are geared toward the heavy-duty market, as highlighted in orange and blue. More recently, some additional Delphi OE product has been added to the program, primarily because the applications are in the right phase of their life cycle from a reman offering perspective. This pie chart shows the aftermarket demand distribution by vocation. These recent new product introductions cater to key vocations like construction, ag, refuse, and on-highway, giving us the opportunity to diversify sales across these applications. We have a comprehensive line of OE and all makes injectors. A complete cross-reference section is located in our current all makes flyer. One of the latest additions to our all makes flyer is our Reman F2P product for pack car applications, which includes part number cross-reference, features and benefits, as well as reference to our external seal kits. Another example would be Reman product for John Deere. If after diagnostic testing and external visual examination, a previously installed injector is going to be refitted, the external O-rings must be replaced with new. External O-rings should never be reused. The All Makes brochure indicates the correct seal kit to use. We've been developing the first in a series of online All Makes training programs to support our line of remanufactured electronic unit injectors. We've partnered with Lincoln Tech to bring you a comprehensive program intended to benefit your company and your customers, including sales personnel, counter people, and installers. The first class will concentrate on Caterpillar 3406E, C13, and C15 applications. It is a self-paced online program containing over 14 how-to videos. Let's take a look at an example video showing injector removal.
Now we're going to actually remove the injector hold down bolt using a 3/8 ratchet extension and 9/16 socket. We loosen the hold down bolt and remove the injector hold down crab. Got the hold down bolt. The crab can be a little bit of a problem sometimes to get out. So we'll go ahead and try to pop the injector up and out using a lady slipper. So just get a hold of the side of it and lift, and you can see the injector move. So now we can actually remove the whole injector.
The class will be hosted on the Delphi Technologies Academy Learning Management System website. We'll be having additional information on signing up for the class in the near term. The last topic I'd like to cover today is our Hartridge test equipment. The test equipment market has evolved significantly over the years. We've needed to add products to our portfolio to allow the network to focus on diagnostics and replacing units when necessary. Hartridge product offerings have adapted to these changing market needs. It started with the introduction of the HK1400 CAM box, which is an entry-level EUI-EUP test solution. The universal bench compatibility was the first for Hartridge and was aimed at lessening the investment required to get involved in diagnosis and replace type of work. A unique and patented adjustable 11-position cam design is utilized to set the min-max lift. The HK1400 has a comprehensive EUI application coverage, which also includes part number specific all makes test plans, and now includes coverage for Cummins HPI injectors. This helps support the diagnose and replace model of the Delphi Technologies reman program. The next steps in this all-make strategy have been the CRI Master, Expert, and Toledo Huey test machines, all of which have been successfully launched into the market. The mounting setup is made very simple with an injector clamp assembly and nozzle seat. 7mm and 9mm nozzle seats are included with the base machine. If we look at the measuring capabilities, the two test stands are identical as they measure the coil resistance, rail pressure, response time at purge, idle, max torque, and max power type settings. The Sabre and Toledo platforms share more than just hardware. Software is key to delivering the power and advanced capabilities of the machines to the end user. They incorporate a touchscreen interface, simplified displays, and function-specific panels that display installation instructions, videos, and relevant test data in a simple, uncluttered way. Available test plans are fully customizable, limits are automatically created, and can be refined. Here are some of the new Sabre applications that are a big motivation to get an expert or upgrade to an expert should you already have a master. In addition to heavy-duty common rail applications now available for Bosch Twin Coil, F2 Series, and ISX XPI, there are now adapters and test plans available for MaxForce 11 and 13-liter injectors. As many of you may know, the HA230 has been replaced by the Toledo Huey Master, which incorporates electronic metering, automatic test plans, response time measurement, and reduced cycle times. The test stand includes a new fixturing system that aids in clamping and removing the injector. There are a wide range of application kits and 290 plus test plans, supporting diagnose and replace with the Delphi Technologies range of remanufactured Huey injectors. Hartridge also introduced a GDI test stand. As fuel experts, a number of you get asked about gas injectors. If anyone's interested in knowing more, please reach out to us and we'll be happy to share more information. There's a lot of equipment here and a lot that focuses on pull-through of reman product. I believe that diagnose and replace with a reman product helps all of our businesses. There's test equipment available from Hartridge for almost every type of fuel system that is serviced by the network today, which is a really good opportunity for all involved. Things are happening at Hartridge. In summary, these test stands are easy to install, easy to use, fast, and come with the highest functionality usually found in test stands that have a higher price point. What does the future hold? We are actively pursuing hydrogen injectors that are paired with parts of a standard internal combustion engine. We have our first customer, which we hope to be able to announce soon. OEs that make engines have a tremendous infrastructure in place to make ICE, gas, and diesel engines today. If you can keep that infrastructure going and still meet the emissions requirements, why wouldn't you want to pursue that? An interesting piece of news recently involves an engine manufacturer that was able to introduce a hydrogen blend into an existing engine. Be prepared for more innovations. We're committed to being a valuable partner as customer success is at the heart of everything we do. Thank you for your time and attention today, and we look forward to having you visit our booth and connecting with us.
All right, Paul. Good stuff, man. That you had there a well-rounded presentation on the fuel systems, importance of trim codes, the just kind of the North American market, and the awareness of the testing of by the use of cartridge. So that was good. We did have a little technical difficulties going on in the background during the video, but hey, we're here live, and I got Paul Midlars. Paul, do you got anything else you want to comment to the video?
Yeah, it's just we're excited about the future. We see the diesel fuel injection being used for a good number of years, and I think with a complement of hydrogen coming up, I think there's going to be some good business for everybody for quite a while.
Yeah, it's definitely interesting because things are always changing in the fuel system side of it. So, yeah, I guess at this point we're kind of going to open it up for some Q&A and see what we got going on. You want to take the first one there, Paul?
Yeah. First questions: do we offer online training? That is something that I talked about in the video. It's been a long time coming, but I can see the light at the end of the tunnel. So, yeah, hopefully in the very short term here, we're going to be able to announce the availability of the first of our all makes classes that we want to start introducing. The second question talks about, I've often said that legislation dictates technology. What do you see in the future with the adoption of stringent EPA rules regarding lower NOx emissions? Do you see cylinder select becoming commonplace? Well, yeah, depending on who's in office, things change. But yeah, we can see the emissions levels dropping even more. So that's why we really see that, hydrogen is going to be a good possibility in the future. And that's why we're working on those systems now, both our low, medium, and high pressure hydrogen systems. We've even seen some OEMs that have been able to take an existing engine running compressed natural gas and convert it to hydrogen. And we've done the same thing on a 1.5 liter four-cylinder engine, where we changed it from gas direct injected to hydrogen injection. Okay. And it's really been promising. So cylinder select becoming commonplace, I'm not sure on that.
Well, good
Any
stuff,
other
man.
Questions?
I don't see any other more questions coming through.
I wanted to point out that I watched your presentation yesterday, Bert, on the contamination issues, and that reminded me that in school you always learn things, and you wonder how does that equate to your future business or whatever you get involved in. I was working with my 6-year-old grandson. I bought a chemistry set for him, and one of the experiments was to make crystals. And to make the crystals, they supplied a bag of urea. So, it was pretty interesting. I'm going to have to tell my grandson next time I see him, hey, a good example of why we did that test was because if, with regard to what you were saying about putting DEF fluid in the diesel tank causing crystallization. So I thought it was pretty cool.
Well, now we can go back to school and tell his friends to tell their dads not to put DEF in the diesel fuel.
Exactly, because he knows what'll happen.
Yeah. Hey, Paul, looks like we got one more question that came in.
Okay.
Why E3.3 injectors missing the lower O-ring?
Well, I wouldn't say it's missing. It's just the way the system's designed. The way they've got the sealing taking place in the engine, didn't require that O-ring. So if you don't require an O-ring, you don't fit one.
And that's all depending on the manufacturer. That doesn't come back from Delphi, correct? Because I've gotten that question before.
Yeah, exactly. All right.
Yeah, so I guess in that recommendation, it's always important to follow your whoever the OEM's bulletins or service procedures are. So.
All right. The next question had to do with combustion temperature differences in diesel, hydrogen, and compressed natural gas. Well, yeah, I would say combustion chamber temperatures, I believe, are lower in the compressed natural gas, and I'd say diesel, is the highest there, and hydrogen, I believe, is lower as well because you're not going to get the same power output out of those two versus the diesel. Anything else?
No, I don't see anything else coming through. I guess if anything comes up, Paul, after this, I know sometimes questions don't really happen to come across during the actual presentation, but later on, is there somewhere particularly that somebody can reach out to, stop by the booth and maybe reach out
absolutely.
there?
Yeah, absolutely. They can always either email us at dieseltechnical@borgwarner.com, or after the presentation, I will be back on our booth, on the Diesel Expo booth, so I'll be available there for chat as well. All right, there is another question about failures on Volvo applications. I would need some specifics on that. I mean, primarily, typical failures we see are the result of fuel contamination, proper installation, proper handling of the injectors. But yeah, if you come back to me with some specific issues and part numbers, I'd be glad to take a look at that.
Oh, I think.
Okay. It says there on the
D13
E3.3. That's something I'm going to have to take a look at. So I can get with our engineers here, and if you get with me on our chat at the booth, I'll see what I can find out in the meantime and let you know then.
I think a lot of that's got to do with the fuel quality too, Paul, from what I've seen. Just and then guys are on the road. Guys and girls are on the road driving these trucks, and just happens to be that you get a bad batch of fuel, and it just happens to be bad luck. Now, running an approved additive does help out with the longevity of your fuel system.
Yeah, I did see that you sell 3 different additives. I was paying attention during your presentation yesterday.
Yeah, not turning into a sales thing, but a use of an approved additive would definitely benefit the longevity of your fuel system. So
yeah, oh yeah. Mm-hmm. All right. Any other questions?
I think we'll wrap it up, Paul, and I thank everybody for joining up. We've got maybe just one more question that came right through.
Yeah. Are you seeing any valve train wear issues that can cause premature failure on John Deere EUI? I can't specifically put it at that, but I believe that there are some issues on the John Deere during installation of the EUI that in some cases there have been some issues of sticking plungers, and I've seen that related to contamination as well as faulty installation. So, and yeah, potentially valve train issues could be a contributing factor as well. Anything else?
Yeah, commonly through us on the tech line, we get sometimes where they don't the valve adjustment isn't done properly on the injector side of it, so that does contribute to premature failures, or just not working right away from the get-go, where they can blame it possibly on a warrantable issue, but sometimes you just got to go back and recheck that setting.
Yeah, I saw as well, it may not pertain to this one, but I noticed during your presentation yesterday, one of your slides talked about idling the vehicle. I believe it was for a period of time after installation to make sure all the air is out of the system before you start revving it up. So yeah, it's always good to make sure you
Yeah.
bleed all the air out of the system.
And that kind of goes with the, I mean, just fuel systems in general, making sure that you just run them for a little bit, let some of the air kind of work its way out. I know this is a Delphi, but on the Bosch VE pumps, it was quite common where if there was a fuel filter service or just a uh, introduction of air in the system, that air cavitates in the advanced side of it, and even on the DP210s and 200s, right, where that E-clip would, due to the air, start slamming and then
Right.
causing that E-clip to snap and break and causing performance issues on that machine.
Yeah.
So, like I said, Bosch and Delphi and Stanadyne too, some of the other OEMs on the old mechanical side of the pumps.
Yeah, I think there's even a bias spring on Cummins injectors that if you don't bleed the air out, you can damage that spring. So yeah,
Yeah.
it's pretty much everybody's got issues related to air, so something to watch out for. Anything else?
Well, I think that's it, Paul. So no, thank
All right.
you again, Paul, for coming on and doing this presentation, and hopefully everybody took a piece of information so they can use it, put it to use. So hope you guys enjoy the rest of the presentations coming up here today. So make sure to come back tomorrow and check out some more presentations that'll be going on throughout the Virtual Diesel Expo.
Thanks for inviting us. Have a good day.
Have a good day.
All right. Thanks. Bye.